Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science, and machine learning. How do we do that? Number one, we help you build your foundations. We achieve that by making an optimized plan for your learning journey. Number two, we help you prepare and ace your entrance examinations in statistics and data science, like IIT JAM MS, ISI Stat, and CMI MSC Data Science. Number three, we give our absolute best to help you design your career by organizing workshops and certified data science courses. To book a trial class for your preparation courses of IIT MS, ISIM Stat, and CMI MS Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.
The next question is something like, so there are 10 people. So 10 people sit in a row. So these 10 people are P1, P2, P10. Question is, in how many ways can this sit P1 always sit in P2 and P3 such with P4. The question was completely different as in researcher was different, it was simplified it to P1. So any idea how we can solve this question? It's simple. So you have this 10 people sitting here like this. They are not sitting, they are just 10 people who will be sitting in a row, which satisfies this pattern. So the first thing you need to see is P1 always sits with P2. So if P1 sits with P2, you just simply do one thing, just bundle them. They are sitting together. And consider this as one element. So in how many ways can these people sit? I'm not talking about whether P3 sits with P4 or not. I'll come to that later. Now what I want to see is if P1 sits with P2 and I have no other restrictions, in how many ways can this sit? Yes, 9 factorial. 9 factorial. But there is one more issue here. It's P2 can also sit here and P1 can also sit. Internal arrangement. So there will be a number called 9 factorial times 2 factorial or simply 2. So these are the possible arrangements. These are the total number of possible arrangements, given the fact that P1 sits with P2. Now we need to consider the fact that P3 never sits with P4. So n factorial into 2 factorial are the total number of arrangements in which P1 and P2 sits together. Now among these total arrangements, what if I subtract all those arrangements where P3 and P4 sit together as well? If I subtract these arrangement as well, then I will get all the arrangements where P1 sits with P2, but P3 does not sit with P4. So from here I will subtract. So I bundle P3 and P4. So how many ways can this happen? there will be 8, 1, 2, and so on. There will be 8 people. Because I bundle them, I just consider them as one person. So there will be 8 factorial of them. And there will be a 2 factorial in which P3 and P4 sit together. And 2 factorial in which P1 and P2 sit together. Now, if I subtract this one from 9 factorial times 2 factorial, I'll get all the possible number of ways in which P1 and P2 sits together and P3 and P4 does not sit. See, the thing is, this whole expression can be thought of in one go. Just for the sake of making you all understand how to pose this question as a person who is doing it for the first time, I'm going this way. There can be different other ways, so much easier than this actually. So people will just simply do something like the set theory, A against B company. A and B company. A is the set where P1 and P2 sit together. Is also level. So any questions? Please feel free to ask if you have.